Okay, so this is my quick explanation of this question. How could you find the phase shift from a graph or from an equation? So the first part, so these are some like random graphs that I drew using Desmos, and I had to specifically choose that it was in degree mode. So it looks something like this. And then I went about trying to interpreting it. And I obviously made it simple because you asked me specifically about phase shift. And so I verified that the amplitude was 1, just verified all the other parts. Found that the period was 360, and basically I had to look at the two coordinates over there. I did 380 minus 20 because that made one cycle. And then I found the K by doing like a quick conversion with the quick equation, because it's K equals 360 degrees divided by period to get the K. I verified that the C is equal to 0, the max value is 1, the min value is -1. So, it doesn't always work out perfectly like this, but for this example, that's what you have. And at this point, I'll try to find the D. And so what I mean by the fact that you might have different kind of D values is one, well, I go with like the easiest thing that I can think of. So right now, if I look at it like this first coordinate has an x value of 20, right? And it has a sinusoidal function that resembles the positive sine graph. And so the easiest shift that you would choose is 20. It went right by 20, and then it resembles that sine function. And so I'm saying D equals 20 is like the easiest phase shift I can choose, and then I would write my equation accordingly. Just to give you a perspective, if I looked at a print screen of a larger, with more cycles of this same equation, so what I see is that, well, someone else could have picked and realized that the phase shift is 380, because you could also look at it as this graph went right 380 degrees and then continues this sinusoidal function, right? So that is still valid. And so you would say that the phase shift is instead 380, and you would write down your equation. So the two equations are different because the phase shifts are different, but the A and the K and the C values are all the same. And so both these equations would be acceptable ones for this graph. And so, yeah, so this is a really good question. It really helps you reflect on whether you really understand on how to identify the equation from a graph, all right? So it's all about perspective, because what I mean is I could have said, hey, you know what? Maybe I didn't see a sine function. Maybe you're like, oh, it resembles a cosine function. So I didn't write it in the writing, but, and then you would go on to Desmos and try to figure out where that is on the dot, right? And then you could have said the exact same thing. The A is the same. The K is the same, the C is the same, even if you go from like sine to cosine, and you would go to Desmos and try to figure out where that is. Oh, and it's occurring at 110. And so your equation's gonna be like so your equation is going to be the same, except when you go back, you would say y equals cos, and then it went right by 110. So you would say y equals cos, a bracket x minus 110. That way you are saying that D is equal to 110. Okay, so that's all from the equation. And in terms of from the graph, and in terms of from an equation, I gave you this like complicated like equation, but not really, because like the K is factored out, so that's really convenient. So that's the only thing you usually have to watch out for. And then you know that this is the transformed function, and so I noticed that D is equal to 20, and it's just because of like this relation. And so from an equation, it's relatively easier to see. There was like much less work. And then you would say D is equal to 20, which means there was a horizontal shift of 20 degrees. It went right by 20 degrees. All right.